All right, welcome back again. This is part 2 of a video lesson on compositions and inverses with compositions. So now we're going to do inverse with compositions. Okay. So there's this theorem that says f and g are inverses if and only if f of g of x is equal to x and g of f of x is equal to x. So this has two columns. It's a two-column proof, okay? So you got to prove first that this gives you x, this composition f of g of x gives you x, and then the other, which is, notice g is outside and f of x inside, that has to give you x. If you have something else that is not just x, then that means that the functions are not inverses. So all that to say, the following. So are these functions inverses? So notice we have f of x is 1/2 x minus 3 and g of x is 2x plus 6. So then let's do on one side, I'm going to do with, let's see, with blue, I'm going to do f of g of x, which is the first one. Okay, so I'm going to do this one first. And then I'll do summary here, g of f of x. If in the end we only have an x once we've done the algebra, we only have x left, then that means there are inverses. If we have something else that is not just x, then they're not inverses. So what f is going to do is, notice, it's going to multiply by 1/2, and instead of x, g of x. So g of x is 2x plus 6. So I'm going to substitute for g of x. But f of x is also going to subtract 3 from here. Okay, so then from this point on, I'm going to distribute 1/2 times 2x. 1/2 times 2 is 1. And 1/2 times 6 is 3, and then we have a minus 3 outside. So notice what happens to the 3's. Positive 3 and negative 3, they cancel out. So far we have only x, which means the composition of f of g of x is equal to x. So based on this, check. Okay, so this one checks, but then we have to do this one. And we do not have, it would not get x by itself or just x. That means they are not inverses. So with that said, notice that x has a 2 in front of it, so there's that 2, and instead of x, replace that x with what f of x is equal to. So that's 1/2 x minus 3. And again, 2 times 1/2 is just 1x, which is just x, and 2 times minus 3, that's a minus 3. But I forgot here, you have to, g is going to add 6 more to this, okay? And this should be 6, not 3. So 2 times negative 3, that's 6, and then plus 6. So notice the 6 is canceled. So this composition also gave us only x. So which means that since that's the case, then this fulfills the condition of inverse functions. So then last, we're going to say that f and g are inverses, and we just proved it. So okay, so we're doing a proof here. So they are inverses because these two conditions are met. So this is a biconditional, which is with the what the if and only if means. They both have to be true. So let's go on to the second example for this lesson. So let's do, for this one, let's do f of g of x, okay, on this side. And then we'll do g of f of x on this side. So notice that f is going to multiply that x by 2 and then subtract 7. So then let's copy that 2, and then instead of x, what g of x is equal to, which is 1/2 x plus 7. And then it's also going to subtract 7 after that. So then this is equal to 2 times 1/2, again, is x. 2 times 7 is, let's see, this is what, 14. So plus 14 minus 7. So then this is equal to x. 14 minus 7 is plus 7, right? Okay, so again, the condition is this composition has to be only equal to x, but notice we have x plus 7. Since we have x plus 7, then we do not have to do the other proof because this is a biconditional, so they both have to be true. Since this one is not true, it's false because we don't have only x, then we can just stop and say, no, they are not inverses, okay? And that's all for this lesson. I'll see you in class. Bye-bye.